All right, so let's try a few problems here, starting with these ones. And I won't get into the theory here. I'm just gonna show you how to get the right answer. So, absolute value inequality, absolute value inequality. Notice how they're pointing in different directions. When you have it like that, this is called a conjunction. This is called a disjunction. So for when it's like this, what you essentially do is you break this up into, well, watch what I do here. So whenever it's pointing like that, I'm gonna keep 3x minus 1 in the middle. I'm gonna surround it by the symbol 7, negative 7. The goal is to get x alone. So let me add 1 to all three sides. Add 1, add 1, add 1. And these are gone. This is negative 6 less than or equal to 3x less than or equal to 8. Divide every item by 3, and you get the following result. So I'm not sure what else they wanted you to do. Again, this is just my own random problems, right? I'm just making stuff up here. But the goal is to solve we have. I'm not sure if they want you to graph this or if they want you to write it in a different format. I'm not sure. You have to let me know. But this is the solution to that absolute value inequality. And again, right now, I'm just showing you how to get the right answer. If I wanted to tell you everything that's going on behind the scenes, I'd need a lot more time. Over here. When it's pointing like that, you're gonna have an or, okay? And what you do is this. So keep the inside the same for both setups. 2x plus 5, 2x plus 5. But in the first setup, you keep it the same, like that. But in the other setup, you switch the direction and you switch the sign of that number. So that's the difference between this and this. When it's like that, you have one large piece. It's just one large piece. When it's like this, you have two pieces with an or in between, where you keep that the same in one setup, switch in the other setup. Solve, and you're done. So let's see. Subtract 5 from 4. Divide by 2. Okay. Or subtract 5, like that, divided by 2. So here we are. This is the answer to that absolute value inequality. Again, what can we do with this? We can graph it. We can write it in a different way. We can do all kinds of things, but I'm not sure what they want. You have to let me know what they want from you, and I'll make up my own problems. So, done. How about something like, let's go with this one over here. The goal here is to solve by using the quadratic formula. Recall that the quadratic formula is as follows. They probably taught you this a few years ago with like a song from YouTube, but there it is. And we know that this is A, B, and C. So let's deposit these A, B, and C values into this arrangement. And we get the following, like that. Keep the parentheses. Keep the parentheses where they belong. Minus 4AC over 2A. And let's just play cleanup here. Let's just clean up this mess. Double negative is positive. Inside of the square root, we have, that's 25. Negative times negative is positive. 4 times 4 times 6 is 96. Sitting on top of 8. Add those numbers together. That is 121. Do we know the square root of 121? We do. It's actually a nice number. It doesn't have to be a nice number. If this was a number that the square root of it was really weird, like a strange decimal, then maybe your teacher would prefer that you stop here. But I recognize that the square root of 121 is just an average, ordinary, everyday looking 11. Now what I do is I break this up into two parts because I have a plus minus. So I have 5 plus 11 and I have 5 minus 11. And here 5 plus 11 is 16 divided by 8 is 2. And 5 minus 11 is negative 6 over 8 can be reduced to negative 3/4. So what do these numbers represent? They represent the solutions to this equation. They used x as the variable. So x equals 2. So this particular equation had two answers here. We're done 100%. But if it's okay with you, let me take 2 seconds of your time to explain to you what these numbers represent. This original problem here, that has a graph to it. And I can tell you just by looking at it, that the graph of this equation would look something like this. Watch, it's gonna look something like this. Okay, something like that. That makes a picture. Not with the 0. Ignore the 0. Just looking at this stuff. That makes this picture. And you know what this location is? It's going to be 2. You know what this location is there? It's going to be -3/4. These are what we call the x-intercepts of that quadratic function, the graph of which is referred to as a parabola. When you do the quadratic formula, the numbers that you get represent the x-coordinates of the x-intercepts. See that? The x-intercepts, their x-coordinates are bang, bang. Does it always work out this nicely? No, but a lot of times it does. One more. This one here. The goal here is to write the equation of this as a circle in standard form, which looks like this: x minus h squared over a squared. Actually, that's for an ellipse. This is going to be x minus h squared plus y minus k squared equals r squared. Although an ellipse, a circle is an ellipse, but watch what I do here. Here's my recommendation. You see that constant? Move it to the other side. And while you're at it, shuffle pieces around. So x's are with x's and y's are with y's. We can group things around. So we're going to have this: x squared plus 8x plus y squared minus 6y equals 24. Okay, so I moved that over there. I put these side by side, put those side by side. Now watch what I do here. I'm going to go like this. And I am also going to go like that. And I'm going to keep this balanced. So I am going to introduce a special number here. And the number that I feel like using is 16. What I do is I take half of that number and I square it. Half of 8 is 4. 4 squared, 16. But keep this balanced. 16 there, 16 here. Let's try this again. Half of that is -3. But when you square -3, it becomes 9. Keep it balanced. There it is. Now, here's a shortcut. This is called completing the square, because when you complete the square, you can rewrite this trio of pieces as a square. What goes inside? Well, the first operation, always keep the first symbol, addition. Keep the alphabet, in this case x. Now what number goes here? Half of that, 4, and addition. And similarly, it's something squared. Always keep the first operation. Okay, we're using y's. And then what's half of that? 3. Half of that is the same as the square root of that. Either way, that's how you get that number. Equals 49. I'll write this down again because I want you to see that we are actually finished. The goal is to write the original equation as a circle in standard form. There it is. If you want to interpret this, the center of the circle is located at, switch it, -4, comma, switch it, +3. And the radius of this circle, let's just pretend that says radius. The radius would be at the square root of this, or the radius would be the square root of that. The square root of 49 is 7. So you could actually plot the circle. You could go to -4, 3, put a point there, and then from here, go for a walk. Go up, down, left, and right, 7 spaces. Let's just pretend that's 7 spaces, and that would be your circle. So I went through this quickly, but you could always pause it and go back to any parts that you want. So let me know if you have any more questions, and I'll gladly help you out.